This soil is called the Clinesville series. It has formed from red shell bedrock. This bedrock has been sitting for hundreds of thousands of years and slowly broken down and weathered. It's broken down into constituent parts of sand, silt, and clay, and then soil horizons actually form from it. You can see evidence of where the soil came from as you dig down into the soil profile. This is a sample from the soil horizon directly on top of the bedrock, and it has pieces of red shale in it. The soil horizon above that actually has a lot of red shale fragments that we sort of picked out here. One diagnostic feature of the Clinesville series is an excess amount of rock fragments. And the reason that the Clinesville series has so many rock fragments is because that as the red shale weathered, not all the pieces or the layers of it weathered. So individual horizons ended up with a high rock fragment content. The high rock fragment content in conjunction with the rather shallow depth to bedrock are potential limitations for uses for this soil. The rock fragments almost become a limiting zone. So the higher the rock fragment content in the soil, the higher the chance the soil will not be useful for many things. It could restrict plant root penetration. It could actually make the soil droughty and let water move through the soil too quickly because the rock fragments take up a lot of space, but they don't contribute anything to the soil because they're relatively inert. Another soil physical property that we commonly look at is texture. And the way we look at texture in the field is a field technique called the texture by field procedure, which is a flow chart. Basically, what you're feeling for is the presence of the different particles that make up soil. And each particle imparts a different feel to the soil. Sand makes soil feel gritty. Silt, which is a little bit smaller than sand, makes soils feel soft and smooth. And clay makes soils feel sticky when they're wet, and it makes the soil really hard when it's dry. So you're trying to feel for that combination or the dominance of the feel of sand, silt, and clay. So you slowly wet it and try to see if you can make a ball with it. If you can't make a ball with the soil, then it's actually sand, and it means there's so much sand, there's no silt or clay to hold the soil together. Well, obviously we can make a ball with it. So if you can make a ball, what you try to do is make what's called a ribbon. You want to shape the soil into what looks like a hot dog bun or a baguette, a long, thin ball, and then you push it with your thumb and pointer finger and see how long of a ribbon you can make. If you can't make a ribbon, it's actually loamy sand, but if you can make a ribbon, you want to see how long of a ribbon you can make, and usually want to do a couple of these to see if you get similar lengths. These are coming out probably about an inch or so before they break. So I have 3 about an inch long. So we have our texture by feel flow chart, and it wants to know how long our ribbons are. And it made about a 1-inch ribbon, so I'm in this column right here, and you want to determine, does our soil feel gritty, does it feel smooth, or neither gritty or smooth. So based on how this feels, it feels rather smooth, so I actually make it down to silty clay loam. So for an individual soil horizon, we take a soil sample out, we sort of delicately break it apart and try to find out if there's sort of a repeating pattern where we see structural units that are all cohesive, held together, but sort of resemble each other and are roughly the same size and shape. Here we see some what we call subangular blocky. They're kind of blocky, but they have rounded edges on them. And you notice how there are roots running around the sides of them. So that's evidence of that pore space where you have 2 pieces that fit together but not perfectly, and then a root is able to travel in between. There actually is, I believe, down here on the tarp, there actually are some smaller pieces of soil that are aggregates of soil that are about the same size, and there actually is some granular in there too. So there's some subangular blocky, which are the larger pieces, and some granular, which are the smaller pieces. And as you can see by all the roots that are mixed in with this surface horizon, that there's lots of opportunities for roots to make their way down through the soil. So the soil actually has really good structure in the surface horizon. One of the soil physical properties that we commonly look at is called soil structure. Structure is the aggregation of the soil particles that make up a soil, which are sand, silt, and clay. they get aggregated together into structural units, which we call PEDs or aggregates. These PEDs or aggregates can have different kinds of shapes depending on how the soil has formed or how long the soil has been weathering over time. Some structure units are more spherical or blocky, and these structure types, when fitted together into a soil profile, promote vertical water movement, free air exchange, provide space, which we call pore space, for plant root penetration and growth. There are also more restrictive structure types, which tend to be more horizontal in nature. One is called platy, which is constructed of thin horizontal plates that fit on top of each other. They do not promote this vertical pore space where water can move vertically through the soil profile, where plant roots can readily penetrate and air can be exchanged in between the atmosphere and the soil profile. So these structure types tend to be more restrictive. So one of the tools, field tools we use for soil survey and soil science is the Munsell soil color chart. What it represents is a standard reference or language for describing soils. Everybody sees soil color in a certain way, and to use colloquial terms or local terms could be confusing. Things like brick red or sunset yellow, or it's hard to describe that soil color specifically. So we needed a system, and the Munsell color system is the one that NRCS uses in all of its soil survey and soils investigation work. So the way the soil chart is typically organized, it's organized into pages, and each page represents a hue in the color wheel, so yellow to red, and has other colors in it too. And the way each page is organized, there are color chips that you would use to compare to the soil sample you're looking at to help you describe the soil. On any page, there is a hue, and then there are numerical values called values and chromas. And as you go through, these are actually called gley colors. They're they're for the wettest soils, and the rest of the colors tend to go from very red colors, and as you go through, they start to get more yellow until we actually get to what are very olive colors, and even very olive colors are basically green colors. So for example, if our soil color matches this chip right here, the way we would read it, we would first look at the hue, which is 10YR on this page, and then we would read across to the value, and here the value is 5, and we read down and we look at the chroma, which is a 3. So the way we would read it would be the hue first, 10YR, and then the value of 5, and then the chroma of 3. So it'd be 10YR 5/3. That would be the Munsell designation of that chip. So when you're doing a soils investigation or a soils description, the way to do the soil color, you break out a piece of the soil from every horizon, and then you want to characterize the soil color. So there's some proper techniques or standard techniques for describing the soil color beyond just using the Munsell soil color chart. So when you break a piece of the soil out, you want an intact piece of the soil. You don't want to squish your thumb into it or change the shape of it. You want that broken face of the soil so you see actually what the soil looks like. You don't want to manipulate it in any way. In some cases, the soil color may look a certain way depending on the moisture content of the soil. Soils tend to become more pale in color or lighter in color as they dry out. So the only way to really see the true color of the soil, or the standard way we describe it, which is in the moist state they call it, is to actually wet the soil down. So if the soil, especially if it's looking very dry, you want to take a dropper or a spray bottle, gently wet the sample, and you'll notice with this piece, it's very light in color, but once I add some water to it, it actually gets quite dark in color. So you just add a little bit of water at a time, don't oversaturate it, but you'll notice that the color will change. You keep adding a little bit of water until the soil color does not change anymore, but isn't too wet, and then that's the moist state of soil coloring. So to use the chart, there's no right or wrong way to start. You just pick a page that looks like it's close to the soil sample, and then you take the piece of soil and hold it in your hands and put it behind the page. And I believe for this sample, I believe it's matching this chip right here. Let me look at it myself. And I think it's that chip right there. So just like we read before, if it's this chip, then we read the hue first, which is 10YR, and then read across to the value, which is 4, and then we read up and down to read the chroma, which is 3. So for this particular sample, the color, the Munsell notation is 10YR 4-3. So this last example, it's a little darker in color. It looks a little green. This is where it gets tricky about prejudging the soil color, trying to determine which page to use. And like I said, there's no right or wrong page to start with. It looks very green. We'll see if it matches one of the soil colors. I just have to tip it up for a second. And there's actually multiple colors in this. There's different small grains that are different colors. So you sort of pick one that you think is dominant and start with that. And you can describe all the colors, but I believe this is the chip here. And so that would be 5Y with a value of 3 and a chroma of 1, so 5Y31. So just remember, try to wet the sample a little bit beforehand to get the color to develop so you get to that moist color state. It doesn't matter where you start on any particular page, but you'll in time figure out where the best place is to start. And whatever page it ends up being, just remember, no matter what, you find your chip, and then you read the hue first, and then the value, and then the chroma, and that'll be your Munsell notation for each soil color you're doing.